Good afternoon, everyone. Welcome to the presentation for the paper titled PatentQuest, a user-oriented tool for integrated patent search. I am Manajit, and I will be presenting this paper on behalf of my co-authors, David Zimmermann and Professor Fabio Crestani from Faculty of Informatics at Università della Svizzera Italiana. So patent search needs no introduction because it is already a well-established research area. And there are a lot of different kind of patent searches. In this paper or in this presentation, we will be focusing on prior art search. And this kind of prior art search, or in general, patent search is very important because it allows the patentee or the inventor to avoid patent infringement. It also allows a user to gauge the scope of eventual patent claims he's going to make in the patent application. It also helps improve the current idea or invention. And finally, sometimes analysis is carried out by various organizations to estimate the innovation and allocate different kind of resources such as funding for governments and so on. So patent search is still a very ongoing research area, and we will try to add some value to this area. There are a lot of existing systems for prior art search, such as both commercial and open source, such as LexisNexis, eSpaceNet, even Google Patents is there. But these systems are often limited by either a big learning curve or their data collections, which come from various geographical regions. And sometimes the commercial ones are pretty expensive. And for academics like us, it's very difficult to access them sometimes. To elevate these issues, we need a system that can allow searches to be run directly with the input text, that integrates smoothly into the workflow of patent professionals, and that also leverages user feedback and uses various domain-specific contexts to improve search quality. And finally, offers a single point access for heterogeneous information sources. So all in all, the objective of this paper and this presentation is to demonstrate the viability of a more user-oriented system by incorporating direct search capabilities into the user's text editor. For people who are unfamiliar with the patent and its structure, it consists with, well, I hope from the previous presentation, it is already clear what a patent look like. So this whole slide becomes redundant in that case, but nevertheless. So it consists of two sets of fields. One is the text field and another one is the meta information. Within the text fields, we have title, abstract, claims, and descriptions, which are free text. And in meta information, we have various kinds of bibliometric information along with other specific information like classification codes, applicant name, inventors, date, and so on. So before we describe the usage of the system, let me give a very quick overview of the whole system that we designed. So in the front end, which is in blue, which the user usually interacts with, is the interface that the user sees with its text editor. In this case, we are using Microsoft Word Online as the text editor. And then all the queries are basically sent to Solar Indexer. We are using Apache Solar as our basis for information retrieval needs. And additionally, we have a Python wrapper class on top of that, that basically takes care of the query exchanges, the reformulation, re-ranking, and all that thing, and then return back the results to the user input or the user interface, basically. Again, in this slide, we basically present the deployment scenario that we used, but this may not be very useful for everyone. So I'll just briefly give an overview. As we already said, we're using Microsoft Word as our user interface, at least for the text editor part. And the whole system is add-in for the text editor. And our whole backend is running on Google Cloud Virtual Machine. It's openly accessible. And since it's based on top of Apache Solar, all our codes are basically open source and free to modify. So having done with the system setup, let us take a look at how actually the system looked like. It's a very basic overview of the system. Of course, we didn't do a lot of UI modifications, so it might look very basic at that. So we have a text editor, which is basically, we are all familiar with the Windows text editor. And when we load the add-in through a manifest file, we get this kind of a side window with a search button. So whenever a user basically selects a piece of text and presses the search button, he will get a set of results as shown here. Also, the specific term matches are highlighted. So the highlights of this system are that it has almost a zero learning curve. It is as simple as simply uploading the add-in and starting and to just use it. It provides a single point access to patent search without needing the user to switch back and forth between different tasks or different tabs. It supports multilingual search. It also takes user feedback into consideration, as we will explain a bit later. And as I already mentioned, it is built on top of Apache Solar, so it's open source. And it is integrated with Microsoft Word, which is one of the most widely used text editors. So having described the system in part, our system wouldn't have been any useful if you didn't evaluate it. And for that, we chose two kinds of evaluation. One was system evaluation, and the other is user evaluation. First, we'll describe the system evaluation, for which we use the ClayIP 2011 prior art candidate search tracks dataset, which had 1.5 million patents and had almost 4,000 topics, which were basically the whole patents as search queries. And for each such document, we had between 3 and 76 relevant patents. And we also measured our system on the same metrics that were used in the track. So one was mean average precision, and the other one was NDCG. So in the first phase of our experiments, we tried to ascertain which fields are essential in forming a query that can quickly describe our search needs. And we started individually with each title, abstract, description, and claims, and then tried with various combinations of these fields. And as you can see from this table, as we increase the length of the query, which is kind of pertinent with the field that we're using, title is usually the shortest part in the whole patent, and description is the longest, our performance keeps improving. But the best performance in terms of map is achieved when we combine title, abstract, and claims, while for NDCG, it is achieved with only title and abstract. Also, the average query length varies for each case, but this trend of increasing the query length, not that it doesn't always translate to better search results, is in line with the previous research done by Bex and their colleagues, where they showed that there is kind of a tipping point where increasing the number of words to the query doesn't really help. And patents are very verbose documents, so we have to be very selective in which fields we are using for search. The next phase was, on top of selecting this combination of text fields, to add classification codes. And to do that, we basically extracted the classification codes from the patent application, which was set as a query, and then match all the documents that appear in the same classification code using the more like this feature of Apache Solar. So once we did that, our performance increased dramatically. And we also tried with various boosting weights for the classification codes, and our best results were achieved for a query built out of title and abstract with 8 as the boosting weight. We then further tried to incorporate multilingual search, as the data set of the CLAY IP had patents in 3 languages, English, German, and French. And as you can see from these plots, the best performance were obviously achieved for English, while the worst was for French. This also could be due to the fact that the French documents were slightly less than the English documents. But when we tried to combine all the 3 languages into a search system, along with our previous selection of different fields with classification codes, we found out that the title and abstract with the classification codes was giving the best results. So we went forward with that setting. Now, the final or the most interesting part of this system is that it allows the user to interact with the system by giving active feedback. So as you can see in this window, when a search is complete, the user can basically select a few of the results as relevant and then search again, which will then refine this list of results to give a more narrow domain-specific result. And of course, at any point of time, the user can choose to remove any of the relevant documents that he or she has put in. And this is again done with the help of Solar Index. Since I am a bit short on time, I will skip describing this part. So what we saw was that we first wanted to see if actually relevance feedback was helping with all the modifications that we have already made so far. So we tried by selecting randomly 2 documents that were relevant in one study, and in another one we tried to take 2 documents randomly which were not relevant, and to see if our system was actually responding to relevant results. And indeed it was, as is already shown here with the results for both MAP and NDCG. So our system was stable and sane, if I could say so. And then when we added the patent classification system information again, we saw that this gap between these results was even more prominent, with adding relevant documents, adding more value to the search results. So we kept the setting at that point. And finally, to add some bibliographic information, we tried to re-rank these results based on PageRank score, which we calculated from the front page citations that were available in the patent documents. But to our disappointment, the results were not that great. And in fact, increasing the PageRank boost factor was only degrading the results. One intuition behind this could be that we already had achieved optimal results with our previous modifications by including multilingual search and classification codes and so on. So the re-ranking basically didn't add much value to this experiment. And hence we chose not to report this in the paper, but for the sake of clarity, we thought we should present the results anyway. And finally, as our second stage of evaluation, we also asked few users, in this case 4 users, who had fair knowledge of using various IR systems, to give feedback on our system after using that. So with the established system usability scale, we got a score of 72.5, and usually the score ranges from 0 to 100. And our score of 72.5 was deemed acceptable, almost bordering on good. But additionally, we also allotted 2 sets of statements, one for checking the usability of the system and also for the result quality. So these were statements that were incorporated by us. And we scored these responses on a scale of 1 to 5. And you can see the average scores are listed here, where we did decently, I would say. And of course, the system was well received on most cases, but there were some qualitative user feedback on how we could improve our system. One of them was that the user feedback interface was not intuitive enough. And the other one was that we could offer some facilities to visualize the connection between search results, because at any point when we try to add the relevant results and set the search button again, we lose the previous search results. And finally, some minor user interface overhauls were also suggested. We would like to incorporate them in our future work. So to conclude our work, we presented a prototype patent system which performed decently and was shown to fulfill the bibliographic needs for a user or an inventor while formulating a patent document. This system has an ability to incorporate user feedback actively, and also supports multilingual search with the ability to capture various domain-specific cases. And it can easily be adopted to other domains, as we have already done so. There is a sister system of the same prototype which was applied to legal documents and which performed even better than the patent system. And as already mentioned, for future work, we would try to broaden the scope of documents by incorporating heterogeneous sources. We would also like to incorporate the citations in a better way other than the PageRank score. And finally, we would also take into account the user feedback regarding the relevance feedback interface and other user interface improvements. And thank you very much for listening, and I'm open to all kinds of questions.